Good morning all and welcome to this webinar. My name is Ola Lund Reppe and today we will be looking at the operator interface. We'll be looking at repairs and manual inspections, but also at the back end and how to set up both the repairs and manual inspections, as well as some other features of the operator interface. Please keep in mind that the operator interface comes with a lot of different settings and each of them slightly changing the way the interface behaves. So it's difficult to give a demonstration of the full potential. So if you're using the operator interface today or you're not, but you want to get started with it or you want to extend your use, please don't hesitate to contact support and we'll set up individual Teams call and look at your actual use cases and give some advice to what we can provide of features and functionality that would fit your needs. So with that out of the way, let's get started. And I'll go directly into WATS. And we'll have a look at the operator interface and what it looks like and the different features available. So the first thing you'll be presented with opening the operator interface is this black screen, or white if you use a light theme, of course. And you have a menu to the left and you have a search bar in the top. And this search bar is where you can search for a unit and perform different tasks on it. So we have serial number, part number, and revision that are options for search, and we can also search based on batch number. And one of the things that I'll be looking into today is the use of barcode scanners, because we have implemented the ability to use barcode scanners throughout the entire interface of the operator interface. And it's if you have available scanners and you have barcodes on your units, it's really advised that you take the struggle to set this up, because typing in serial numbers greatly decreases the efficiency of using the interface. So I will handle that, but let me first just explain how this works. So you could type in a serial number here, and if you are using exclusively unique serial numbers across your product, actually searching just the serial number is enough. But if I search for a serial number, for instance, 1000 here now, it exists across multiple part numbers, and that will bring up a drop-down box with the different part numbers available. I can select this one to open the unit. But of course, in some cases, you will have more than a serial number decoded into your barcode of your unit. So you could have the part number and revision as well. And we have the ability to set up your barcode scanners to decode that barcode and make the correct search. So before I go into the barcode scanner setup, I want to look at the configuration page. It's the top icon on the screen. And the first thing you need to know about this configuration page is that it is machine specific. It's station specific, not user specific. So in this case, the first time I log into this station with my operator user, this page will be loaded with the station code picked up from my client user. That might not be what I want. I might want all the reports coming from this station to come from a specific station name. So I can override this client name and I can call it, for instance, operator interface station. So in this case, that will override the name, and all reports created on this station will now come from the station name OI station. And I can do the same with the location and the purpose. And resetting the configuration will set it back to my user setting. But if unless this is changed, it will stay like this, no matter who logs in and uses the operator interface from this station. So in addition to the station information, I have the barcode scanner setup. I'll get back to that in a moment. And there is also the option to set the start page. So this means whenever I scan a serial number or type in a serial number and apply, it will go to that page. And I can choose from default, which is serial number history. I can choose to go directly to manual inspections. I can choose repair, or I can choose unit verification or unsubmitted reports. I'll leave it at default for now. And we also have a tab called Advanced Settings. If I go in here, I have some settings that I can change. One of them are for the manual inspections. The manual inspection sequences are created and have a revisioning system. So they are created in draft status, and then they need to be moved to pending and released to be used. So here you can choose what kind of sequences are displayed for the user. And typically this will be released in a production environment, but when you are creating new inspections or testing them, you might want to change this to draft or pending to be able to, on one specific station or more, be able to test sequences before you release them into production. So I will change this to draft now to let us be able to run manual inspection sequences that are only in draft mode. In addition, we have what we call a locked process. I'll get back to that as well, but that is a way where we can limit the number of options for the operator when starting different inspections and repairs. So now I want to just briefly explain barcode scanners and what it takes to set it up. There are two different things that need to be set up for a barcode scanner to work. And one of them is the decoding of your barcode. So whenever you scan one of your barcodes, the barcode scanner will typically send to the keyboard a code read from the data read from the barcode. And that data may contain more than just the serial number, and it might need to be decoded. And to find the decoding of the barcode identifier, we need to go into the REST API. You can use that from the help menu. You can find the API documentation. And this is going to be a little bit technical. And if you don't want to bother about the technical part, please keep in mind that you can contact support and we will help you get this set up. But under barcode identifiers, I can use the get function to get the barcode identifiers that are in the system. And I'll just call this one, and you will see that there's just one barcode identifier in the system today. So there's an array of them returned, and there's one in this array. And in general, it consists of 6 different regular expression patterns. The first one, pattern, it matches on the entire data coming from the barcode scanner. So if you are using multiple different setups at the same time, you will need to have a value in this pattern as well, matching the entirety of the data coming from the barcode scanner. And if it's null, like in this case, it will be evaluated no matter what. So since there's just one, I don't need to match the entire path. I can match any path coming from any data coming from the barcode scanner with this one. So once the first pattern is out of the way and this barcode identifier will be evaluated, it consists of different regular expressions that matches the part of the data that contains the serial number in this case. So in this case, the format of my barcode scanner's serial numbers are serial number / part number / revision, and if available, batch number and process. They're separated by slashes, and that is also in the regular expression. It groups and splits the input based on forward slashes, and it maps the first match into the serial number, the second match into the part number, the third match into revision, fourth match into batch number, and so on. And you can, of course, configure this to match your specific barcode formats. So once this is set up, you can actually also verify it from identify barcode function. So if I make a trial barcode here now, let's call it serial / part number / revision, and I try it, it will decode, and we can see here that it's decoded serial into serial number, part number into part number, and revision into revision. So this seems to be working correctly. So that is one part of the setup. The next part of the setup is the communication with the barcode scanner. And for that, you need your barcode scanner to be set up with a prefix and a suffix. So a barcode scanner will typically scan using a keyboard input. So if you put your cursor in any text field and do a scan, it will of course scan the data into the field. But to be able to use the scanner without using your mouse, putting focus in the right places, you will also need the prefix and the suffix. So the default ones for WATS is Control Q for the prefix and Control Y for the suffix. You don't have to use that, but you'll have to use something that is not conflicting with any other keyboard shortcuts, and you should not use Enter as suffix. That will cause some problems. So as long as you keep to those rules, it should be fine. And once you have the scanner set up with a prefix and a suffix, you can go into these settings and click the Configure Scanning button. And this will bring up this configuration window, and I can just scan this barcode. It's a little bit hard to get it reading off the screen. There. That is inconvenient. There we go. So once it scans, it will show up the actual configuration of the barcode scanner. And here we can see that it's set up with Control Q as the prefix, and then you get the code, and then you get the suffix. And this looks all right. I press save, and now the setup is done. So now I can try to scan one of my barcodes, and this should load the unit. So as you remember, in our settings, we had the start page set to default, and the start page default is the serial number history. And serial number history is in general the same as the serial number history in the reporting section. It's all the reports in the system for this serial number, and you can see them chronologically with the latest report in the end. And you can see the different processes, and you can see the status for the test and the time and the station and so on. And from here, you can of course also open the reports and inspect the actual measurements. So in addition to the serial number history, we also have what we call unit verification. And that is a way where you can get a grading and see some additional information about the unit. So if I click this one, it will grade the unit based on these tests. And as you can see here, this one is graded A with 5 stars and OK. And the text states all processes have passed their tests, and they've been executed in the correct order. And this is picked up from what we call unit verification rules, and they are in the control panel. And here you can, down to every part number and every revision, you can specify which tests should be performed. And using the process index, you can also specify the order of these. So in this case, since both the pre-burn-in and installation tests have the same process index, WATS will not evaluate the order of these two. It doesn't matter, but the burn-in test needs to be the third one, and the final function test needs to be the last one. And they have all passed in the first try, and it's a grade A unit. Let's scan another one to. So in this case, we can see that we have actually a failed report in the serial number history. So the final function test failed the first time around, but it's been retested and passed. If I go into the unit verification now, it states grade C. All processes have passed their last test, but one or more earlier runs failed. And we can see the same here. We have a warning here, final function test, total count 2 tests and 1 failed. Going into the station configuration, if I change my start page to unit verification, and we'll scan another one. And now you can see I go directly to the unit verification instead of the serial number history. So that's how the start page works. In this case, we have a grade E. It's not okay. Some of the processes have not passed their last tests. So in this case, we have the pre-burn-in test. It looks like it's not run at all, but all the other ones have passed. And one more example. Yeah, the same thing for this one. Okay, so that is the unit verification and the serial number history. And now let's go and have a look at repairs. And before I go ahead and look at repairs in the operator interface, I want to take you into the control panel to look at where they are set up and a little bit how you can configure it. So in the control panel, I'm going to go into the process and production menu, and here I have my processes. And the processes contains of both the test operations. We have something called work in progress tracking operations and repair operations. And in this case, I'm just going to look at the repair operations. So let's filter out the other ones. And you can see that there are two of them in the system. One is called module production repair, and one is called RMA repair. You can create as many of these as you need, and they can be configured differently in terms of their repair categories, their codes, and their settings. And in this case, let's go look at the module production repair and the settings that are available. So first of all, to make this a repair process, this is repair operation needs to be checked. And further, there are some options. First of all, there's the UUT binding. That means whenever I do a repair, it's advised to link it to an actual failed test report. That gives a lot more value to the analysis of the data. So you can choose for a repair operation if it's required that there is a UUT binding, if it's optional, or there should not be one. In this case, I'll leave it at optional. The bill of material list binding is also something that you can set up to be either required, optional, or never. And this helps making the logging more consistent. Instead of manually typing in component reference for your repairs, you can, with the boom binding, select it from a previously uploaded boom list and making it consistent. Same thing you can do with the vendor. You can when you do repairs, you can log the vendor of the component that is failing or being repaired. And you can do that as an optional, required, or not included step as well. And then you have a component reference mask, meaning that if there is no boom list or I have turned this boom list binding off, you can use a regular expression to validate the input from the operator. That means you can limit it to have a letter and 2 or 3 numbers or whatever mask that you need available. And with the mask comes also the validation text. So this text should describe this validation code. So in this case, it's point star, meaning any character is allowed. So when we run this repair, it will try to use the boom binding. If there's no boom list on the product, it will fall back to the component reference mask. Another thing we can set up is the miscellaneous information that should come onto the header for this repair. So in this case, the operator will be asked to input an origin, and this is also point star, anything allowed mask. So you can put anything into that origin, and I can add more fields. And this will show up when you start this repair operation for the operator to enter. And then the last thing that you can change for the repairs are the repair categories and the repair failure types. So by default, it comes with these 6 different categories, and all of them containing a couple of different repair codes. And you can turn these categories and codes on and off, and you can also delete and add categories and add codes. So you can configure this list as you want, really. And for each of the repair codes, you can also choose if image attachments are optional, required, or not allowed. So that is how you can configure the actual repair codes. Once you are done, save, and this repair process will be available for use in the operator interface. So let's go back to the operator interface, and I will scan one of my units and look at the serial number history. Yeah, let's do another one. I want to have one with a failure. So let's take this one. It's failed the final function test. Also failed the pre-burn-in, but it's retested and passed. So let's repair based on this failed step here. So to start a repair, I click the repair icon in the menu. And now you can see that there are two repairs showing up. And we can remember from the control panel that we had these two repairs available. We had the module production repair and RMA repair. Potentially you can have more, and this list can be longer than you want. And in some cases, you would want the operator to do as little selection and as little clicking as possible. So that is where the locked process comes in. So let's go back into the control panel and go to the advanced options. And here I have my locked processes. So what I can do here now, I can say that on this particular station, I'm only going to allow module production repair. Going back into the interface, clicking repair now, it's already selected here. There's nothing else to select. Click next. Oh, let me go back. So here is where also the MISC info, we remember that origin was specified as a MISC info field. So I can type in something here and go next. And here we come to the identification of the UUT report. As we remembered, we had that as optional, so I can skip it. I don't have to select one of these. I can identify it just by a test operation and product. But as I said, if it's possible, you would want this connection. So I'll select the final function test and confirm the selection. And now we are into the interface where I can log my repair. And as we can see here, I get the step name that has failed, and I have a drop-down list for my repair categories and codes. So this was the list that we can modify in the repair. And I have my component reference. And as you can see, once I click it, I get the bill of material list listed here, since this product has a boom list. So I can select from this list. So let's just select a category. Let's select one of these components. I also have this vendor list, so I can search in a vendor list. This is global for WATS, so you simply upload the entire vendor list that you have, and you'll have them available. And you have the option to add a comment or to attach files to this repair code. And also you have this preview pane to the right that gives some valuable information. You can preview the repair report. So this is the result of my current repair. I can see different data that is put in here. I can also see a viewer of the linked UT report, the failed report. So this is the failure that we are fixing. I can see the serial number history to inspect what has been going on in the future, or in the past. And I can also see something called related repair history. So here I can see that for this same unit, previously in history, I have 85 repairs, different repairs, and you can see for the different step names which repairs have been performed earlier. So this can be a good reference to get some clues on to what has been working in the past. Once you're happy with your logging, you click the Add button, and then you have the option to submit the repair report. Once that's done, you'll go back to the serial number history, and you can see my repair showing up in the history. And this unit would typically be ready for a retest of the final function tests. Let me try one more time to show you some more features. Just gonna make sure that this. So for this unit, I have a unit tested that has subunits to it. So I want to show you how a repair would look if you have an assembly consisting of more than one part. So I'll do the same thing. I'll just run the repair. Next, I'll select the step, confirm. Sorry about that. So let's try again. Yeah, so here we go. So now, once this repair loads, it's based on a UT report that has subunits. So once we get into the repair logging, you will see that we have the same view as before, but in addition to the one repair code we had earlier, we also have the option to add repair codes to the child units, the subunits that are attached to this main unit. So I get the categories and codes for the main units. I can also go ahead and log on the subunits. And I also have the option to replace these units. So I could go ahead, for instance, and replace this serial number. Click the replace button, and I'll be asked for a serial number for the replacement unit. And I can, of course, use my barcode scanner. And I hit replace, and that replacement will be logged. And if I now submit my report, I can see my repair, and opening the repair reports, I can see the serial number taken out and the serial number replaced. So that is what I was going to show when it comes to the repair process. So now we're going to go and have a look at the manual inspections. And what manual inspections are simply sequences, test sequences that can be performed manually by an operator and logged directly into WATS. And you manage and create these sequences in the control panel. So let's start off in the control panel and have a look at that. It's in the process and production menu, and it's called the production manager. And it handles more than just the manual inspections, but now let's just hide everything else and open this webinar inspections. And I have created two different inspections for this demo. One of them is called global sequence. And what I've done here is that I've created one sequence that I have marked as global, and that means I can reuse it in other sequences. I can nest these sequences into each other. So if I have generic sequences, a small part of the sequence that is often repeated in different processes, you can create one generic one and reuse it in different tests. So, and also I created this inspection called the webinar inspection, and this then uses the global sequence inside itself. So I will explain that later. And we can see here that we have different colors on of these two ones, and it represents the status of the sequence. So in this case, it's blue and it's in draft mode, and that means I can edit it and I can do any change to it, and it's where you typically have it when you develop and change the sequence. When I want to test it, I can move it to pending, or I can move it all the way to release. But keep in mind that once a sequence is released, you can no longer change it. So when you want to change a released sequence, I'll have to, if I want to change this global sequence, I'll have to make a copy of it, which will in terms create a draft. And as you can see, it will increase the version of this one. So now I can do the changes on this one, and I can move it to pending. And once I release it, it will automatically revoke the old one and replace it. So if I release this one now again, you can see that this one is revoked and the version 2 is released. So I didn't do any changes, but I moved it back to draft and re-released it to make changes. If you keep it in pending or keep it in draft, you won't have to inflate the version number whenever you change it. So you can keep it in draft until you're done and then release. Sorry. So let's look at the options for these different sequences. In the sequence overview, you have the option to give it a name and a description, and you can set it as global. And there are some options to the behavior of the inspection. The repair on failed means whenever a step in the inspection fails, what is going to happen? Are you going to present the operator with the option to repair it right away? And you can make that optional, required, or never. If you have this optional or required, you can also specify which repair operation to use, making it not necessary for the operator to do that selection. Subunits grid is a grid showed up on the start of the inspection, giving you the option to add subunits. And this option is you can force the inspection to be stopped at the first failure and not allow it to continue. I'm going to leave that one off for now. And also we have this auto create new manual inspection. If it fails, that means if you have this off, you will, once a report fails, you can submit it, and whenever you are ready to retry it, you can pick up where you left off and just complete the test. If you have this checked, the next time around you run the test, it will restart from the first step. So I'll demonstrate that as well. And the rest of the settings are more for information logging. So I can log the UUT MISC info. I can include the MISC info from the UUR. I can log the operator, and I can log the step description. So some minor configuration details. The next tab is the sequence designer, and here is where you create the actual sequence. I'm not going to go into detail. I'm just going to show the designer and how you open it. So you download the sequence. It will end up as a local file, and you open that local file, and that will open in a separate editor, and it looks like this. And you will have the sequence and the steps showing up, and you can set the properties of the different steps, and also you can drag the different step types into your sequence. So in this case, we have a pass-fail test. Then we run the global sequence, as I mentioned. So we have this global sequence running inside our sequence, and then lastly, there's a numerical test in the end. So I'll just close this one again. And once the sequence is set up and the settings are selected, you need to set up some relations. And the relations are what decides which product has which inspection related to it, or which station for that part. So in this case, this inspection has two relations. So I have related it to two part numbers. One of them is the one that we have been looking at as a demo product. And I also have this other relation, MI test. It can be a good idea when you are developing tests to set up something like this, because then I can run the tests without polluting my production data. So I can when I'm developing, I can run this test on the MI test, which will show up as software debug process, and it's easy for me to delete or exclude this testing from my production data. You can set up as many relations as you want, and these relations don't have to be to part number. So in this case, when I scan a unit for this part number, this test will show up. If the relation was not there, it would not. But the relation could also be to the station code or the revision or something like that. And lastly, instruction PDF. So here you can upload one or more PDF files that are available as instructions for the operator during the inspection. So in this case, I have one PDF, and the different steps of my tests can show different parts of this PDF or different PDFs. So I will come back to that as well, showing the inspection. So this is a setup, and once this is set up, this inspection should be ready to run. Note that now this webinar inspection is in draft, so typically my operators on the floor in production would not see this before I have released it. But as I mentioned earlier, in the configuration, I have set it up to be able to run on draft. So if we go back to the operator interface, to scan a unit, and if I click the manual inspection tab now, yeah, sorry, no sequence found for that unit. So let's check our configuration. It's set to draft. 1, 2, 3, 100. Yeah, I know why. Going back to the operator interface, when looking at the repairs, we did a little configuration here. We went into the locked processes and locked this station to only module production repair. Now, to be able to run this sequence, I also need to either turn off the locked processes thing. I can do that and make everything available, or I can also lock the test processes that should be available for manual inspections. And in this case, we had this inspection running as the process called manual inspection. So I could have enabled this one, but let's just turn it off and back. There we go. And I'll click the manual inspection. And now you can see that the test is automatically opened. If there was more than one inspection available, I would have gotten a drop down selecting which one, and that could of course be configured with the locked processes as well, showing only the processes you want the operator to see in this case. So before the test starts, the start page of the test is loaded, and here you have the subunits grid. So here I can actually add subunits by simply scanning serial numbers. So I could add subunits by scanning it. I'm going to delete that one again. I have the MISC info field here as well, and I can add the origin, I can add a comment, and any other information that you would like the operator to log. So I'll click the start test, and once it starts, you will see the entire sequence outlined on the left-hand side. You will have the step that you are on in the center, and to the right you have the instructions. And here you would typically have the instructions for the operator to how to exactly perform the test. So even though all the test steps are coming down to either Boolean pass-fail tests and numerical input, a string value test, they can be as complex as you want in how it's performed for the operator. So here you can have images and any information the operator would need to perform the test. In this case, I have simply dumped the the settings for each step for you to see in this example instructions. So in this case, we are looking at the pass-fail test. And as you can see from the setup, the PDF is selected, and I've used the PDF search string. So I'm searching for pass-fail test, and that is what opens the instruction at the correct page. I can also use the page number if I want to do that. So for this one, I'll just pass the step. The next one is a numerical step. It can be set up with 1 or 2 limits. It can be logged with no comparison as well. And in this case, it's a high and low limit. I will put something in between and make it pass. The next step is a message pop-up, which shows a message and lets you select a couple of options as response. Another pass-fail test. String value tests can be limited by regular expressions filter. In this case, it's not no limit. Just type OK. Add subunits is like the subunits grid. Here I can use my barcode scanner and add subunits. And we have wait step if you want to enforce the operator to wait for some certain amount of time. And we have the option to attach files, so you can upload any files you like to the system. And last, there is one more numerical step in this test. I will pass this one as well and confirm. And once it's done, you have the option to submit the report. And at any time, I can abort or stop the process in the middle of the process. Sometimes you're not unable to finish a test. And if you do, the test will show up in unsubmitted reports, and you can continue it from there, or you can scan the unit again and just click the manual inspection, and it will pick up where you started. But in this case, I'll submit it, and we can have a quick look at the report and how it will be displayed. So now we have the next test here is the manual inspection. You can see that it comes from our station. You can see the time, and I can open the report, and it will show up just as any other automated tests that you are uploading to the system. You have the same header data. You have the subunits. So as you remember, we scanned the subunits during the test, and it's entered in here. We have the MISC info from the start page, and we have the different steps and the values logged. So this is how you perform a manual inspection. And I'll do one more round just to illustrate what happens when you fail it and the options that we can present for those scenarios. So I'll scan this one as well, and I'll start the manual inspection. And this time I will just start the test. And on the first step, I will, instead of pass it, I will fail it. And as you remember, when we set up this manual inspection, we set the repair on failure option to be optional. So once I fail this one, what automatically happens is that the repair interface is opened directly into the manual inspection here. So now I have the option to just log a repair right away, or I can skip it since it was optional. So if I skip it, I can continue the test. Let's pass this one. Let's say that everything else passes just normally. And submit. So now we have the manual inspection that has failed, and we can of course perform a repair based on that as well. But if we did the repair underway, that will already have been logged as one process. So that is in general what I wanted to show you when it comes to the manual inspections. And before we finish, I just want to mention a couple of more things, because in the operator interface and in WATS in general, not every feature is enabled by default. So there are some more features that extends the use of the operator interface and the use of WATS in general additionally. And I just want to mention it so you know that it exists. And if you want to investigate it in more detail, please reach out to us and we can have a talk about these features as well. So first of all, as you might know, WATS is at least as it comes out of the box, it is serving you your data and your analysis based on the historical data. So we pull all the test reports that you have uploaded, and we kind of present a state for the unit based on what we know from the test performed. But in addition, you sometimes want to have a current state describing your unit. And by enabling a module that we call production in the operator interface, we introduce this. So what we introduce then is that we keep a record for every unit in your database. So let's just scan on this instance that I'm looking at now. I have enabled the production mode, and you can see there are some new icons. So if I scan a unit here, what happens is that this dialog box shows up. So once production is enabled, it will require that the unit exists in the system for me to be able to handle it. So in this case, the unit doesn't exist. There is no serial number 1000 on AB123, and I get the option to add it. And this dialog box can, of course, also be removed, so an operator cannot add a unit, so the unit needs to be there to be able to do any processing of it. And of course, this greatly increases the possibilities you have to validate and make sure that all the data in the system is 100% correct. So in this case, I'll go ahead and add the unit. Let's give it a revision name and add it. And now we are suddenly unlocking the box build interface that you have probably seen in the product manager. So in the product manager of the control panel, you can, for each product, set up a template for the assembly of that product. And you can see in this case, the AB123 has 3 subunits, 1 of this kind and 2 of this kind. And you can scan and assemble this unit in this interface. And now, once this production environment is activated, the validation is much more strict. So now I cannot add a subunit that does not exist in the database and has the correct status and so on. And in addition to the box building, we also now have a unit info. So for each device, you will have the option to write data logged to that device, not to the product and not to the process, but to the actual device. So for this serial number 100, I can see the data related to it. I can see any tags written to the serial number or tags written to the product or revision. And I also have, in addition to logging what test process has been running on this unit, I can also introduce the phase term. So I can say that this is shipped, it's scrapped, it's repaired, and not, last but not least, finalized, which states that the production is done and it's completed. So this introduces quite a lot of new features to WATS, and of course the drawback is that you can't just turn it on, because all this information about the unit needs to be communicated. So typically this includes some sort of integration or customization for every customer. Great. That concludes what I wanted to go through in this session. I hope it's provided some value for some of you. And if you want to know more about anything that we have been discussing here, please reach out either to me directly or to support@virinco.com, and we'll set up a meeting and discuss individual cases. Okay, then I'll just wish you fine day and see you next time. Bye.